Hello everyone. Welcome back to Dr. Liu's VCE Physics channel. Today, let's learn together about the 2025 VCE Physics examination. We will focus on questions related to parabola and circular motion. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. The correct answer is C. Here is the breakdown of the physics behind why the acceleration points where it does. Understanding centripetal acceleration. In this problem, the ball is moving in a circular path at a constant speed. Even though the speed isn't changing, the direction of the velocity is constantly changing. This change in direction requires a centripetal acceleration. By definition, centripetal acceleration always points toward the center of the circle, point O. Analyzing the points. At point P, the top to stay in a circular path, the ball must be pulled toward the center. Since the center, O, is below point P, the acceleration vector points downward. At point Q, the bottom again, the acceleration must point toward the center. Since the center, O, is above point Q, the acceleration vector points upward. An engineer, Sam, is designing a new track for a high-speed racing car. The car makes a circular turn of radius 240 m on a flat track. A top view of this situation is shown in Figure 7. The sideways force between the tires and the horizontal road surface is measured. The car and driver have a combined mass of 800 kilograms and travel at a constant speed of 30 ms/1 around the curve. To solve for the sideways force in this question, we need to recognize that the sideways force mentioned is the centripetal force required to keep the car moving in a circle. Therefore, we use the equation of centripetal force to calculate the total sideways force. When a car takes a bank turn without relying on sideways friction, the net force, created by the resultant of the normal force and gravitational force, acts entirely as the centripetal force. If we visualize this using a triangle of forces, we see that this horizontal resultant is equal to milligram tan theta. By substituting our known values for speed and radius into the centripetal force equation, we can precisely determine the necessary banking angle. Centripetal acceleration essentials. The definition: even when an object moves at a constant speed, it is accelerating because its direction is constantly changing. The direction, by definition, this acceleration always points directly toward the center of the circular path. Vertical motion: the tennis ball at the highest point, the acceleration points downward toward the center. At the lowest point, the acceleration points upward toward the center. Horizontal turns and track design. Flat track mechanics. For a car on a flat surface, the sideways force required to maintain the turn is provided entirely by the friction between the tires and the road, bank track. The frictionless turn to preserve tires. Tracks can be angled so that no sideways friction is needed. In this scenario, the combination of the normal force and gravitational force creates a resultant force that acts as the centripetal force. The force triangle. When visualized as a triangle of forces, the horizontal resultant is found by multiplying the gravitational force by the tangent of the banking angle. Design conclusion. For a standard racing car on a turn with a radius of 240 meters traveling at 30 meters per second, a banking angle of approximately 21 degrees is required to eliminate the need for sideways friction. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.